Alright, day 2 is all about quadratics, so let's just dig on in. There are 3 different names for solutions to a quadratic equation: zeros, roots, and x-intercepts. All 4 of those words will be used on your state exam and county exam to make sure you understand that they mean the same thing. So zeros, roots, x-intercepts, solutions, all of those are the same exact answer. Next, remember a quadratic equation can have 0, 1, or 2 solutions because it can never cross the x-axis, which is 0, and those solutions are imaginary. It can cross the x-axis 1 time, or it can cross it twice. And here are examples of a picture of each one: 0, 1, and 2. Remember, the discriminant of the quadratic formula will tell us how many solutions we're talking about. So our quadratic formula, if you remember, is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, where the discriminant, or d, is what's underneath that radical, because out of the entire problem, what's underneath that radical is the most important part. If the discriminant is 0, the square root of 0 is 0, and it goes away. So our solution is literally negative b over 2a, or that one solution, that vertex point. If the discriminant is positive, meaning it's greater than 0, that means there are 2 real solutions, what you get when you add negative b plus the radical over 2a, and what you get when you subtract them. If d is less than 0, then that means the square root is negative, so that's imaginary solutions. That means there are no real solutions, however, there will be 2 imaginary solutions, which we'll get into later. So, the first thing I want you to do is state the number of solutions each quadratic equation has below. Pause the video now and work out these problems, and then check your answers. Alright, in number 1, the discriminant is 24, so there are 2 real solutions. In number 2, the discriminant is 0, so it means there's 1 solution. In number 3, the discriminant is negative 16, so that means there are 0 real or 2 imaginary. And in number 4, the answer is 64, so there are 2 real solutions. The difference between number 1 and number 4 is when you take the square root, you get a rational answer for number 4, whereas you get an irrational answer for number 1. Meaning you can take the square root of 64 and solve the problem easily. And number 1, you can't take the square root of 24 as easily. You have to jailbreak it and break it down. The radical never truly goes away, so that makes it an irrational solution. If you have any questions about the discriminant, now's the time to ask Miss Lewis. Otherwise, remember, we learned 4 different methods for solving quadratic equations. One was factoring, which we talked about on Friday. The next one is the square root property. We get the square term by itself. And then remember, there are always 2 possible solutions, the plus or minus of our square root, which we will look at next. In the square root method, we take the square root of both sides. So in number 5, the square root of 25 is plus or minus 15. And in number 6, the first thing I need to do is divide by 3, giving me x squared plus 25. Take the square root of both sides, and I get plus or minus 5. Now take a couple minutes and do numbers 7 and 8. Please pause the video before checking your answers. In 7, we get plus or minus 3, and in 8, you get 7 over 2, plus or minus 7 halves. If you have any questions on 5 through 8, now's the time to ask Miss Lewis. It is actually using your calculator. Remember, we get the equation equal to 0 on one side. We type it in our y equals equation, and then go to our graph. We can look at our graph and determine how many solutions there are. Sometimes we can easily see where it crosses the x-axis. Sometimes we cannot. So we use the second trace 2, which is the 0 option. We move the cursor to the left side and hit enter, the right side and hit enter 2 times, and then you repeat it for both zeros. So solve each equation by graphing. So in this first one, it's already equal to 0, so if I go to y equals, clear out anything that's there, x squared plus 10x plus 9, hit my graph button. If you notice, you see it nice and neat crossing at two spots. That's -1 and -9. All this means is that it factors, so you don't have to use graphing for this one, but you can. Our steps say second trace 2, and I find my cursor here. Pick whichever one you want to find. We'll find this one first. I'm going to hit my left arrow until that cursor's on the left side of it. Then hit the right arrow until it's on the right side. Hit it twice, and it tells me the zero's at -1. You do it again, hitting the left arrow until the cursor is on the other side of that 0. There we go. Hit it to the right side and guess. -9. In number 10, it works out nice and pretty again with it being -4, -3. However, with number 11 and 12, it doesn't work as pretty. In number 11 and 12, first off, it's not equal to 0, so you need to move the 1 over for number 11. That gives us x squared plus 9x minus 1 as our equation. Oh my goodness, x squared plus 9x minus 1. When I look at my graph, it looks like it kind of crosses at 0 and kind of crosses at -9, but let's see. Second trace 2, the left side and the right side gives me the 0.11 or the 0.1. Second trace 2 over here gives me the 9.1. Now, these are tricky on the calculator because they're decimals. So if you are uncomfortable using the calculator, remember the quadratic formula, or our other techniques also work. Factoring in this case does not work because it's decimals. In number 12, I would move the 6x over, and then you have -x squared plus 6x plus 10. And if you wanted to, you could get rid of the negative sign, which is what happens here with the x squared minus 6x minus 10. Either way, you get -1.4 and 7.4. If you have any questions on those techniques, please ask Miss Lewis now. The next is the quadratic formula. We talked about it at the beginning of the lesson, but now we're actually going to use it. Remember, our equations are ax squared plus bx plus c. So that's where our a and our b and our c come from. And we're going to solve each using the quadratic formula. We're going to do this first one together, and then I'm going to let you try some on your own. So looking at number 13, 3 is A, -10 is B, and 5 is C. So when we plug it in our formula, we get 10 plus or minus the square root of 100 minus 4 times 3 times 5 all over 6. 100 minus 4 times 3 times 5 is 100 minus 60, which is 40. So the square root of 40 plus or minus our 10 over 6 will reduce to 2.72 or 0.61 when you type it in the calculator. Again, you'll get two answers from this because you can get plus or minus the square root of 40. Now pause the video and try number 14 on your own before checking your answers. In 14, you should get 2.1 and -0.6, and this is how you set it up. If you have any questions on the quadratic formula, now's the time to ask Miss Lewis. Now, kind of going to mix them up and give you some problems to figure out. 15 through 18, I want you to pause the video, solve them by any method of your choice. Remember, graphing and the quadratic formula always work. Factoring is a technique that only works sometimes, so you have to be careful with it. So pause your video. If you have questions while you're working, ask Miss Lewis. Otherwise, check your answers when you're done. So here are our answers. For 15, first off, you have to move the 4 over. It does not factor, so I use the calculator or using the quadratic formula. You get -1.24 and 3.24. 16, you can do any way you want. It does not factor. Quadratic formula won't work. There's no real solution for it. There's an imaginary. If you were to graph it, you would see that. 17, if you move the 9x over, you can factor it by greatest common factor, which would give you 1/4 and 0. or you can use the quadratic formula. Here, c is 0, so be mindful of that. Or you can graph it and see where it crosses the x-axis. In 18, you can move the 48 over and factor it and solve it by hand. You can just solve for x, so 48 divided by 6 is 8. So then x squared is plus or minus the square root of 8, which is plus or minus 2.83. If you have any questions on these four, now's the time to ask Miss Lewis. Next, it gives us a little word problem, which, as you know, is probably going to be how we, see it on our state exam. It says the dimensions of a rectangle are x and x plus 7. If the area is 78 meters, find the value of x. Well, remember, area is length times width, so x times x plus 7 would equal 78. If I were to multiply that out and solve it and get it equal to 0, that would give us x squared plus 7x minus 78 is 0. Then you factor that, and you get the values of x can be negative 13 or positive 6. Because we're talking about dimensions of a rectangle, we're not allowed to have negative answers. So the only value of x that exists is x is 6. If you have any questions about this problem, please ask Ms. Lewis now. If not, I would like you to go and try number 20 on your own, and then check your answers, which you can see now. If you have any questions, please ask. 20 is 9 or 3. 9 or negative 3, with negative 3 not working. Alright, what's the axis of symmetry? The axis of symmetry is whenever you fold something in half, it's perfectly symmetrical on both sides. If you remember, negative b over 2a, that first part of our quadratic formula, is our axis of symmetry. The vertex is that balance point. It's that minimum or maximum. And we can use negative b over 2a and then substitute to find the y value. So now I want you to take a couple minutes and find for questions 21, 22, and 23 the vertex and the axis of symmetry for each function. Pause the video now and then check your answers. So in the first one, in 21, the vertex is at negative 4, negative 1, x equals negative 4. And if you remember, this is a minimum of x equals negative 4, negative 4, negative 1, so minimum of negative 1. Because a is 1, it opens up. In 22, we have 5, 2, so be careful because the a is negative. And then x equals 5 is our axis of symmetry. This makes this a maximum of 2 at x equals 5. And then last but not least, number 23, the vertex is at 2, negative 7, making the axis of symmetry x equals 2. If you have any questions on 21, 22, or 23, now's the time to ask Ms. Lewis. Next, I want you to be able to graph a quadratic equation and be able to match the graphs to those equations. Remember, graphs of x squared, if it's positive x squared, it goes up. If it's a negative x squared, it goes down. In 24, we are given that y equals x minus 2, x plus 4. So our zeros are at 2 and 4. So our answers can be either B or C. It cannot be A because that crosses at negative 2 and positive 4. It's not our zeros. Because there's no A term out here, we're assuming it's a 1, so that's positive. So that means B is our answer. If you have any questions about number 24, please ask Ms. Lewis now. Otherwise, I would like you to try number 25 before checking your answer. In 25, we're given the equation in vertex form. So it's a little bit different than factored form. In vertex form, you're actually given your vertex. Remember, h is always the opposite of what's in the parentheses. So in this case, that would be 2, 3. The transformations, if you were asked, are up 3 and right 2. And it always starts at the origin. So in this case, that would be C. You need to be comfortable with all three forms of a quadratic equation. Standard form, which is y equals ax squared plus bx plus c. Factored form, which is the last question, number 24, or vertex form, which is what you see here. You need to be able to identify graphs and pull any information off of them. If you have questions on those three forms, now's the time to ask Miss Lewis.